So in 4.2 day 2, our goal is to find out how a derivative will tell us if functions are increasing and decreasing and if we have extreme values. Now, what does a function look like if it's increasing? And there's two, that's right, but there's two ways it can go up and go this way or go this way, right? This is increasing at a faster and faster rate. This is increasing at a slower and slower rate. Okay? Well, what's true then about the slopes of an increasing function? They're positive or they're negative. Which are they? That's right. F prime is greater than 0. So if you take a derivative and you look to see where the derivative is positive, then you know your function is increasing then. So this is not a bad section, except that they really should have done the first derivative test in here, so we'll kind of preview that. Okay, what does the function look like if it's decreasing? It goes down, but it could go down this way or that way. What's true about the slopes of a decreasing function?
They're negative.
They're negative. So I don't necessarily memorize it, I just look at the pictures. F prime is less than 0. By the way, this is your justification. Yes? It's the way it was done. Yeah, the last 15 minutes. Okay? Okay. How do you know if a function has an extreme value? What is an extreme value? That's the just, if on the exam, if they ask you if function's increasing or decreasing, this is what you would write. The derivative is positive or the derivative is negative. You can do it in words or you can do it with symbols. That's your justification. Okay. How do you know if a function has an extreme value? What is it? Oh, by the way, what's an extreme value?
It's like,
Okay. Well, any max or min, actually. So if they ask you, find the extreme values, you're going to find all of them. And what must be true about the derivative if you're looking at not at the endpoints, but if you're looking in the interior, if you have a max or min, here's a maximum, here's a minimum, here's a maximum, and here's a minimum. What's true about that? Tom, what's true about my derivative at those max or min points? What's right? The slope is either 0 or it does not exist. We're going to do 2 problems. That's it. Or f prime does not exist. Now, here's the thing. Just because the derivative is 0 doesn't mean you have a maximum or minimum. Does it? What if I take this function? This function, what's it? Well, how would you describe this function? It's what? Increasing. So if I'm going to have you do this little line chart, here, we'll call that C. Here at C, the derivative is 0, but what's true about the left sides? Since the function is increasing, the derivative is positive, and the derivative over here is also positive, do I have an extreme value? No. To have an extreme value, what must happen? Pardon? I don't have a max or min here. I have a horizontal tangent. That's right. They have to change. What? You said it right. Let's look back over here. This is a positive slope. This is a negative slope. This is a negative slope, positive slope. So to have an extreme value, the derivative must change sign. Derivative, let's put that in parentheses. Slope must change sign. I don't care if it's undefined in the middle area, it's just got to change sign. Some of you don't like the fact that the derivative sometimes doesn't exist. But on that absolute value function, let's do this one right here. So we'll call this point C. This does not exist, so I'll say undefined. But what's true about the slope on the left side? Positive or negative? It's positive. On the right side, it's still a maximum. So it doesn't matter if this is 0 or undefined. If your derivative goes from positive to negative and that's 0, it's going to be a nice, smooth, nicely behaved function. If it's undefined, you're probably looking at a corner. Could be a discontinuity too, so be careful. Okay? That's the big thing. It leads me into the first derivative test, which is tomorrow. So you've already got a preview of that. No, the first derivative test is tomorrow. It's not a test. It's how do you know if you have a relative max or min. So the homework problems look just like this. Find your local extreme values. Tell me where the function's increasing and where it's decreasing. That's what the homework looks like. Well, we're going to use calculus. Even though you could use a calculator, we're going to use a calculus and find the derivative. So you ready? F prime of x is what? 6x squared plus 6x minus 72. So to find the extreme values, I'm going to find out where my derivative is 0 or where it's undefined. Is it ever 0? Is it ever undefined? It's a polynomial. Good job.
That's what I remember.
Very nice. So it's fine. The only thing I can look for is where the derivative is 0. Now, how are we going to find the zeros of this function? You know it's a parabola. Let's factor out a 6. Could you divide by 6? Yes, you could. You can't divide by x, but you can divide by 6. So it's x squared plus x minus 12. Plus 4 minus x minus 3. Check. Did that work? And now we want to find where that makes that 0. So by zero product property, x plus 4 is equal to 0, which is x equals negative 4, or x minus 3 equals 0, or x equals 3. And then we're going to put a little line graph in here, because I want to know where this is increasing and decreasing. So I'm going to draw a line. I'm going to put in my zeros, negative 4, 3. I'm going to label this f prime so I don't get confused, and I do tend to forget to do that. And you could test regions, or you could say, I know it's a parabola. And it's a parabola opening up, right? So these are my zeros. What's true about my derivative on this side? Is it positive or negative?
Wait, how do you know it's
No, my derivative is positive. The slope of the derivative is negative. That's not what I'm asking.
Yeah.
Pardon? I'm asking this is the derivative. This is a graph of all the slopes of the tangent lines of this function. Of that function, sorry. So is this positive or negative?
Negative.
No, its slope is negative.
There we go.
So let's test it. Let's put in negative 10. Let's put in negative 10. Negative 10 plus 4, negative 10 minus 3. Is that multiplied? We're looking at the derivative function, not the actual function. Yeah, that's positive. What's an easy one you could test in here? 0. And what's true about this function? It's drop below. It should be negative, but I put in 0 here. That's positive 4. That's negative 3. So that's negative. And I'm going to label these as zeros, by the way. And then this is what? Positive. Okay. So where's my f of x is increasing, not f prime. Increasing where? From negative infinity to where? Now, we do not have agreement on whether or not you can count the negative 4. So you can close it or leave it open. It doesn't matter. It gives you a 0. You're actually stopped if you're talking about motion. Because this is a parabola, isn't it? That's the cheating way to do it. The straightforward way to do it is just to test the points. Where else is it increasing? Where else? 3 to infinity. And it's decreasing. It's decreasing between -4 and 3. Are there any extreme values? Does the sign change at all anywhere? Yes. This would be an extreme. I'm not sure if it's max or min, but this is an extreme. That's not the value. Are we asking for values here? Find the local extreme. I'm not sure exactly what this. Usually it's the x's on this one, but you could find the value here. We've used a calculator, and here's another extreme location. So we have extreme values at x equals -4 and x equals 3. Does anyone want to venture a guess as to what's true about -4? Is it a max or min? What if A thinks it's a max? What would be true about my function? It would be increasing here, and then 0 out, and then decrease, right? Yeah. And it would decrease, and then it would change to increasing. We're going to be doing this. So this would be a minimum. This is not being asked at this point. That's what they call the first derivative test. But we will do it tomorrow. I just want to give you that preview so then tomorrow's easier. Okay, let's try the next problem, because there's only 2 problems. And why am I focusing on the exponentials? Because on the exam, there's lots of exponentials. Because they're the only ones that are interesting. So what do you have to do to that? Taylor, what do you have to do with that? Take the derivative. So let's do it. Have we forgotten our derivatives already? That's right. Is it positive or negative? Negative. Okay. No, you don't subtract it. You just take the derivative of this. Because it's the chain rule. It's the derivative of, and maybe you'd prefer to see it this way, e to the -1/2 x. What's the slope of this line? -1/2. This is not the power rule. This is the exponential rule. Do you remember the derivative of e to the f of x is e to the f of x times the derivative of that function. It's not the power rule, it's the exponential rule. It's not a power. No, this is 2 to something, 2.7. A power, so a power would be x to the e. That's a power. I don't like that. Like x squared. This is like 2.7 to the x. It's a different rule. This is an exponential. This is a power. Yes, it's easy to get confused. If the exponent's a variable, it's an exponential. If the exponent's the base, it's a power. Okay. No, I just take to do the derivative of e to f of x, it's e to f of x back again times the derivative of that. Okay, so f prime is equal to, well, I might just leave that. It's -1/2 e to the -1/2 x. I prefer that. Okay, guys, ready? What's true about e to the -1/2 x? Do you remember what it looks like? It looks like what? It's a reflection over the y-axis. This is always positive. Right? Are you okay with that? Because it's always positive. So what's true about f prime? It's always, in this case, it's a negative times a positive. It's always negative. Which means that what's true about f of x? It's always decreasing. No max. No min. And I believe that's all there is to this section. The rest of this section. The homework's asking you to find the extreme values and where it's increasing, decreasing. And so we can look at some homework problems. That proves that it's always decreasing, because that's negative. Yeah. So the question is, have you started your homework? And do you have questions on it? Are there questions on the mean value theorem?
We have the rest of the hour to work.
You will. We're going to have a guest speaker, and we're going to have just a quick little homework quiz. It's formative, but it's pretty straightforward.
No, because I.
It does. It's not on that. It's on 4.1. So, do you have questions on the beginning of 4.2? Yes, no? Did you do your homework? That'd be a better question.
Yeah.
Do you have any questions on the first rounds?
The 4.1 day one.
No, 4.2. Okay, you're gonna have. We'll give you the quick little quiz, and then you can work. And that's it. And we're gonna go on to 4.3 tomorrow. I've already talked a little bit about it, so that's not gonna be too terrible, I don't think. It's not that bad. To get to the word problems, you got to do the word problems. You don't like the word problems. But he has.